Hey everyone, my name's Eric Bull, and my presentation today is on Colorado Gambel oak ecosystems. So we can go ahead and jump in with a few key themes that I know I'll come back to a few times throughout the rest of the presentation. And the first is that as a species, Gambel oak is extremely versatile. It grows in a variety of different ecosystems and with a variety of different associated species. It typically grows in the 1800 to 2700 meter range here in Colorado, where I live, though it grows at a much wider range across the Southwest. And that's a pretty big elevation range compared to some other similar trees and species that grow, particularly here in the mountains of Colorado. It can exist as a shrub, as a pure shrub at under 1 meter, or commonly upwards of 20 meters. I think typically in Colorado it's under 20 feet, though it gets much taller and even over 100 feet in the deep southwest. It's adapted for both drought tolerance and drought avoidance, as evidenced by its ability to exist in totally different forms in different places. And particularly relevant to today's conversation is it's capable of resprouting from roots after a disturbance as well as from acorns. It's also known as a very durable species, even indestructible, that is very effective at resisting human control. So here's a map from the USGS that shows its range across the Southwest and uh, just across the border into Mexico in a few places. Um, my presentation is specifically on Colorado Gambel oak, but I did find some of the differences across this range pretty interesting. The farther south you go, the taller the trees get, and the much more common it is for Gambel oak to resprout from acorns as opposed to roots. And this is speculated that the more regular summer monsoon rain kind of makes that growth from acorn a little bit easier. Here's a map from the Colorado State Forest Service of Gambel Range in Colorado. You see that it's particularly widespread on the western slope and is a major component across almost all of mountainous Colorado, comprising about 10% of total forest cover. So here are 6 examples of different Gambel oak ecosystems that were pulled from one document, which is cited in the reference slides at the end of the deck. We don't need to go through every single one, but a couple of themes here that I thought were interesting. Um, Gambel oak can exist in a pure stand or as what you might call a climax species, more commonly in the foothills or in places where you don't see a lot of bigger forest trees taking hold. But when you do get into those forested environments, Gambel can exist as what you might call a subclimax species alongside bigger trees like ponderosa or Douglas fir. So here are a few associated species, and this is by no means a comprehensive list given um, how versatile this species is. But it shows you a little bit of the range of different plant species which grow alongside Gambel oak. And on the animal side, Gambel oak ecosystems are very well known for being widely used by animals at different times in the year, both for cover and for food. Uh, uh, Specifically, the widespread acorns that the species produces and the grasses that often grow in those environments. And one of the major reasons for human control and management of these ecosystems that became abundantly clear doing the research pretty quickly was efforts to try to open up a lot of these very dense Gambel oak patches so that livestock or wildlife could uh, more easily move in. So now we can get to fire and how Gambel oak ecosystems react to it. And the first point here is that Gambel oak is the primary disturbance, or rather, fire is the primary disturbance affecting Gambel oak, and with other disturbances like drought, frost, insects, and disease having supplemental roles. Fire plays a major role in maintaining these ecosystems by promoting regeneration, increasing age diversity, and also, very interestingly, increasing the density and cover of Gambel within these ecosystems, which we can get back to more shortly. In moderate burning conditions, uh, Gambel oak is very resistant to fire. It can actually serve as a green belt between neighboring ecosystems. And the tree itself can often survive low or moderate fire. But heavy and continuous fuels do occur in these ecosystems. So high intensity fires also can occur. And when they do, they're often very severe and very hard to fight. A lot of Coloradans might remember in 1994 the South Canyon fire near Glenwood Springs in a Gambel community that was very hard to fight and burned very intensely and unfortunately killed 14 firefighters. So, a few more notes on fire in Gambel oak ecosystems. It can burn at any time of year if conditions permit, but the leaves are a major factor here. The leaves stay on an oak tree after the growing season, so late in the season they can serve as dead and dry fuel in the crown of the tree, and this can particularly be a factor early in the season if leaves sprout and then are killed off by a late spring frost, which can leave dead and dry fuels in the crown of the tree into the hot, dry summer months. So when severe crown fire does occur, it can open up patches in these Gambel communities and provide successional opportunities, either for more Gambel or for other grasses, forbs, or shrubs. But fire almost never kills the roots of a Gambel oak tree. And one major factor in these ecosystems is that most associated species are not resprouters. So it gives Gambel a major recovery advantage when severe fire does happen. And many mixed Gambel patches return as pure Gambel oak, or at least more pure Gambel oak, for decades or centuries to come after a major fire. So, a few notes here on the natural fire regime and fire history of Gambel oak. And the first point here is that because oak trees are a little harder to read in terms of fire scars and other fire evidence, there's just not as much knowledge on what the fire regime was like before European settlement. But since European settlement, fire regimes are estimated to be well over 20 years in Gambel oak ecosystems and up to 100 years, with fire suppression in the last century having increased this range. One notable exception is that in ponderosa pine ecosystems where Gambel oak also exists, the fire frequency range is far less. And I wanted to talk for a second about fire suppression, which I found one of the more fascinating topics doing my research. And as we have seen in many other types of forested environments, fire suppression has made older, denser, and more homogeneous stands. But I found this particularly interesting because, as I mentioned a minute ago, fire itself can also make Gambel oak stands more dense. And I think part of what's going on here is that when frequent fire occurs, you tend to get more young, resprouted Gambel oak kind of infilling in a dense way. And when fire suppression occurs, Gambel oak can also resprout and grow inward, but perhaps at a slower rate and with much bigger trees. But I think it also points to the fact that fire suppression just may not have as uniform an impact on Gambel oak ecosystems as it does on some other forest types, particularly because it's just such a versatile species. So, a few final notes here on some current issues, questions, and challenges that I found particularly interesting going through the research. Um, and the first one is on how effective human control of Gambel oak can ever be. It's obvious that there's a lot of effort being put into controlling Gambel oak across the West. It's a very aggressive species, and efforts to mechanically remove it, use prescribed burning or herbicides, or even shoot browsing by goats can be effective in some situations, but they tend to be oh, only effective for 10 or 15 years before Gambel returns, and it's nearly impossible to entirely remove Gambel without using very intense herbicides that are obviously very challenging to use. So time may tell kind of how effective humans think that removing or controlling Gambel oak is, but that ought to be a kind of ongoing conversation over the coming years. In terms of climate change, we obviously know that temperatures are generally rising in the West, but the exact climate future for Gambel oak may be a little bit less clear than it is for some other species, and that's in part because our lack of historical knowledge makes it a little bit harder to model the future. Um, and while it's a very hardy species that I don't think anyone worries is going to disappear anytime soon, it's not totally clear if it will follow the path of what we expect some other species to be, which is to kind of migrate slowly north and upwards in elevation as uh, temperatures rise. One final question that I found really interesting is whether an additional disturbance might eventually appear that might shape Gambel ecosystems as much or more than fire has. And this might specifically be an insect or a disease that affects Gambel oak. We haven't really seen that as much out west or in Colorado in Gambel oak communities as we have with some other tree species. But I did come across some speculation that this could at some point occur and might radically change the future for Gambel oak. Okay, that's it. This final slide is my references if you want to take a look. And the references for each of the photos were on the original slides. And thanks so much for watching, and I look forward to all the feedback.